Welcome. Today we'll be talking about gas laws. Now, gases are described by three basic properties, which are volume, temperature, pressure. Right? Volume, we all know that it's either length times length, as the volume of a cube. A cube which is length times breadth times height. Also have volume of various other shapes like cone, cylinder, and the rest. Temperature. I'm going to take. I'm going to be doing a separate video on that. We'll talk about heat and temperature. But today we want to focus on pressure, and then we talk about gas pressure measurement. So pressure of a gas is the force the gas exerts perpendicular per unit area. Okay, so from let me see, grade 10, we know that pressure equal force over area. Okay, we know pressure is force over area. Yeah. But for this study, we want to derive another another formula for pressure. But before we go there, let's look for the unit of pressure. So we know the unit for force is Newton. We know that for area is meter square. So it is Newton per meter square. There are also other units for pressure, but that will be discussed after we prove the next formula for pressure. Okay, so we need to bring in a derived quantity, which is density. Density is mass over volume. All right, so we need to bring density into this formula. So now, how do we do that? We know density is mass over volume. We can't see mass here, we can't see volume here. But remember that force has its own formula, because force also is a derived quantity. So let's talk about force. Force is mass times acceleration. I used to tell my students, if your mom calls you, what will be your response? It will be M-A. That's just the formula for force. Mass times acceleration. Now, acceleration now can be represented in two forms. If a car moves or accelerates, so that's horizontal movement, or a train is moving, that's horizontal movement. But right now, when we're talking about gas pressure measurement, we're not just talking about, we're not going to be dealing with that form of acceleration. The acceleration we're dealing with is acceleration due to gravity. So it means that when we're solving, you're going to see it later that height is actually required in solving gas pressure measurement. Okay, so for that sake, we're going to be changing this A to G, which is acceleration due to gravity. So force. Now, someone will be asking, I did the same thing. Okay, if two quantities shares the same unit, then we can equate them to each other, such as work done and energy. So the units for acceleration is meter per second square. The unit for acceleration due to gravity is 10 meter per second square, or 9.8 meter per second square, or 9.81 meter per second square. So force now is mass times acceleration due to gravity. Okay. Sorry about that. Now you can see that from density we're already having mass. It's already looking like that. So I can say my pressure now. I can say pressure equal M times G over my area. Mass times acceleration due to gravity over the area. Now, mass has been taken care of. The next thing we want to look at is volume. How do we incorporate volume into this? Now, we know that volume is length times length times length, which is having a unit of meter to the power of 3. So, now, if volume is length times length times length, we know that length times length is area. So we can say that volume is equal to area times length, or area times height. So since we're talking about, since we're taking acceleration due to gravity, so we're going to be taking height. Okay, so how do we bring this in? So we are going to say, we're going to multiply this by height over height. So let me explain this. Now, it is mathematically allowed that you bring in something, but the moment you're bringing in something, there is a need to balance it. For instance, we have 4x plus 10 equal 14, and you're asked to find x. Okay, so we're having plus 10 here, but we need to take away this 10. How do you take away positive 10? Is to introduce negative 10. So it's now become x plus 10 minus 10 equal 14. But this is not right, because whatever you do to the left, you do to the right. So we introduced minus 10, negative 10. So that's the same thing you're going to do to the right hand side. Introduce negative 10. So it now becomes 4x equal 4. And then here comes it again. We want to make x subject of the formula. So it will now be divided by 4. So whatever we do to the left, we also do to the right. Divided by 4. To make it balanced, so 4 eliminates 4, and then x equal 1. So the reason why I did that was to tell you that it is mathematically allowed that when you introduce something, you just need to make it balanced. Okay, someone will be like, okay, but you said whatever we do to the left, we do to the right. Why is height not added there? So it's technically the same thing. What I'm trying to say is pressure times height equal m times g times height. You see, it's the same thing. I introduce height to the right hand side. I did it to the left hand side. But remember that the pressure, we want to derive another formula for pressure. So it's going to be the same thing over height. This height cancels this height. And then we are back. Sorry, I omitted that area. We're back to the same thing. Okay, so let's proceed. This case now, you can see that we have area and height. So I can bring them together to become mgh over volume, because we established the fact that volume is area times height. I hope you're following. So we know that density is mass over volume. Do we have mass? Yeah, we have mass, yeah? Do we have volume? We have volume there. So this is mass over volume. This quantity is what gives us density. So I can say pressure equal density times acceleration due to gravity times height, which is the same thing as, okay, this is the unit, the symbol for density, and then I'm having my acceleration due to gravity, and then I'm having my height. So this is what we call the pressure formula, or the same thing. Let's talk about the unit. The unit is Newton meter per second square. We've done that. And then another unit again is I just want to introduce something. All right, so this is what I just want to introduce quickly. 1.013 times 10 raised to the power of 5 Newton per meter square is equal to 1 atmosphere, which is the same thing as 1.013 times 10 raised to the power of 5 Pascal. So it means that another unit for pressure is Pascal, which is the same thing as 760 millimeter area. So this is everything concerning pressure. So now let's dive into gas pressure measurements. Meet you in the next video.